All right, testing. This thing is on. Good afternoon, everyone. One of the things I usually do before I start presenting like this is I do a quick head count of the audience. Since I can't see most of you because of the bright lights that are in my face, I'm just going to assume there's about 700 of you. Sounds about right? Awesome. All right. Again, good afternoon. Thank you so much for joining me here in this 1 hour about Doom. So I'm going to try my best to see you all. Who is here just to see Doom on a big screen? Okay, who's here for the technology behind it all? That's the best I've got so far. Nice. All right. So this is about how we brought Doom to Maui. It's running on my phone. In the demos I'm doing, I'm going to show the Windows version just because it compiles faster, runs faster, and it's easier to show. Should you want to see it running on like a medium-level Android phone, come talk to me afterwards. I can show it on my Motorola. Works pretty well. Now, since we're in the age of AI, let's just AI this and get it over with. So I asked Copilot, hey, can you port Doom to Maui for me? And he replied with, well, I can't, but these guys did it, so maybe you can talk to them. That's me up there. Okay, so where did this story start? This all started with a friend of mine named Wesley, who you might also run into at different conferences, that told me, hey, you know what would be fun? There's this game called Doom. It's completely open source. How about we take it and we port it to .NET? So I cleared my schedule and we went to work. And the thing we did, that's what I'm going to talk about today, in part. And this is all about setting expectations in a bit of a more funny way. What I'm going to talk about here is not how we ported C code to .NET. That's the part that Wesley did. That was the hard part. I did the easy part. I took his .NET code, which was a WPF application, which is what you saw running when you entered the room and you saw the Doom demo running. That was WPF code. I took that code and ported that to Maui. And that's what this talk is about. How did I take a WPF application, ported that to Maui? And this is an extreme example of an application because it does some graphic stuff. It does some stuff that your average business application doesn't. And that's what this makes an interesting use case. Right? Again, nice to meet you all. My name is Nico. I'm a .NET architect at Inetum Belgium, which is a big consultancy company. I've been a Microsoft MVP since 2014 in developer technologies, that is. In Belgium, I'm part of a Visual Studio user group for one of the biggest .NET communities over there. And I'm also part of Techorama Belgium and Netherlands crew, which is a conference similar to this one. I wrote a couple of books. None of those matter anymore. I brew my own beer, I ride a bike, I play guitar, not all three at the same time. You can find me on some social media stuff. Reach out there. Now, who has not heard of Maui so far? And I'm not talking about the island. So not this one. Anyone? No one? A couple of people? All right. So the problem is with Maui, if you want to look into it and you search for it, and you enter Maui in your search engine, you basically get information about the islands. And that's not the Maui that we mean. Now, if you want to look for .NET MAUI, you just enter problems with Maui, and then you find links to .NET MAUI. Right, kidding aside, Maui is the successor to Xamarin, in particular Xamarin Forms. It's the newest version. It's been around for like 2 years now, I guess. Some of the Maui folks are running around here somewhere. So Maui is your multi-platform application, meaning that we can write platform-native applications and run them on Android, iOS, Windows, macOS, and probably even more that I'm not aware of. And that's important to know. These are native applications. This is not a web view rendering HTML and whatnot. This is actually native stuff. And this is how they do it. So starting at the bottom, let me see if I can laser point this. There we go. Bottom layer, these are your operating systems. Your mobile, your desktop operating systems. On top of Android, iOS, and macOS, there is the Mono runtime, which is now also just .NET, I guess, since Microsoft owns Mono now. On top of Windows sits the .NET Core CLR, which is used by the WinUI SDK and the WinUI framework. On top of that is your .NET base class library, and that's where it gets interesting. On top of that layer sits .NET for Android, .NET for iOS, .NET for Mac. This used to be Xamarin Android, Xamarin iOS, Xamarin Mac. They just renamed it, but it's the same thing. And for the Windows part, this is just WinUI 3. In case you haven't heard of WinUI, WinUI is the most recent desktop framework. So you have WinForms, WPF, and then there's WinUI. Those are your supported options for writing desktop applications for Windows. And WinUI is a target that MAUI uses if you want to deploy to Windows. So 4 different targets. On top of that sits an abstraction layer, and that one is called .NET MAUI. It abstracts away those 4 separate layers into one common API target. On top of that .NET MAUI abstraction layer, that's where we write our code. That code gets compiled into .NET MAUI, into platform native, and so on and so on and so on. And at the end, you have you're calling into Java methods for Android. You're calling into your Swift methods for iOS and for Mac, and you're basically already calling C# for Windows, so no need to translate that. So that's a bit of setting the scene. Good news, I only have about 2 or 3 slides left. So the rest of this talk is mostly live coding. What I did to present or to build this presentation is all of this stuff that we did, all of this porting it to MAUI is on GitHub, and I will share the link at the end. So I went back through the commits, and I bundled most of the commits together into demo steps, and I'm just going to repeat what we did, the problems we ran into, and how we fixed them. So with that, let's jump to Visual Studio. And I just realized I forgot to increase my font size. Sorry for that. All right, let's see. Is that big enough? It's okay? I can't even see you, so I saw a thumbs up here somewhere. If it gets too small, just shout. I'll increase the font size. That's okay. All right, so let's talk about this solution. This was the starting point. So this is a solution with 2 projects, a class library called DoomSharp Core, and a WPF application called DoomSharp Windows. And this was the one you saw running. It was running in debug mode, so when you entered the room, this is what was running. DoomSharp Core is the actual Doom engine that was ported over from the C code to .NET code. This was basically done line by line. We did some optimizations to get it a bit more object-oriented, but it's basically a one-on-one clone on how the original Doom engine works. And that all starts with the Doom game class. This one contains the game loop. And everything starts in the run methods. This is your entry point into the game. The first thing it does is it tries to identify what version of Doom you're trying to run. And it does this based on a WAT file. A WAT file is basically a small database-ish thing. WAT stands for where's all the data. And this contains all the maps, the sprites, the positioning of enemies, of weapons, power-ups, and whatnot. Everything is in there. So we really depend on this file. Now, you will not find this file on our GitHub for the simple reason that Doom is open source and is freely distributed. The WAT file isn't. You can find it online, and that will be the shareware version. If you want to use the full version with a modified source engine, then you need to buy it still. That's the way the open source license works. Now, what we are doing is we're checking the name of the WAT file. So in case it's just called doom.wat, it's a registered version. If it's doom1, it's shareware. There's the retail version, and then there's doom2. Doom and Doom2 are basically the same game. Small optimizations in the engine, but it's basically the same game loading in a different WAT file. Going into the file system, I have a WAT folder, and here it is. This is my WAT file. So I'm running the shareware version here in this demo. So that's important to know. Now, how does my application know where this file lives? It's in the launch settings.json. We add an environment variable that we can use to pick it up. And this was one of the first problems we encountered. This is a WPF application. This is Windows, full admin rights, full steam ahead. This works. MAUI is sandboxed. When you run an application through MAUI or WinUI, you get a sandbox environment. You don't just get access to the file system, not with the same APIs. So that was the first big problem. And we'll fix that in a couple of minutes. All right. As for the XAML in this WPF thing, it's basically just an image. It's an image element, and we're just swapping out bitmaps. We're using writable bitmap for WPF part, which was yet again another problem because writable bitmap doesn't exist in MAUI. But it's just a writable bitmap. We're just replacing the pixels in it and just swapping out the image X amount of times per second, which is what gives you your gameplay. All right. Let's start doing this. So for starters, I'm going to add a new project to the solution. And this is going to be a MAUI app, which I will call doomsharp.maui. Okay. For those of you who have never done MAUI but have done Xamarin, you will notice that the template has changed. I was getting some errors, so let's see if this builds. While this is building, so you used to get... what now? Oh, I see. There's some stuff left behind. Right. This will end up working. What you get is now only one project. With Xamarin, you used to get multiple projects, a shared one, an iOS one, an Android one, a Windows one, and you need to set one specific head or project as a starter project, and that's the platform you're building and running on. With MAUI, they've done some project magic, and it's all bundled together in one project now, which simplifies this thing greatly. If you want to do platform-specific stuff, there's the platforms folder, which contains all the platforms. And in there, you can do your platform-specific stuff. Only the specific platform folder will be included in your build if you're building for a platform. As you can see up here, once I change the startup project, that is, there we go. I'm currently running on Windows. So if I build now, then my Windows version will be built. If I change to an Android emulator, then Android will be built. If I change to an iOS device, then iOS, and so on. You got this. As mentioned, I will keep doing the Windows stuff. Now, before we can get started, I need a reference to the Doom engine, right? The Doom core thing. And did you know that you can just drag and drop projects onto each other to add a reference? Mind blown. I discovered this like 3 weeks ago. So that works. Let's just zoom in again. In the WPF version, there's a folder called View Models. We are not doing MVVM in any way. We're just calling it View Models because it's kind of what we're doing with it. But I'm copying this folder into the MAUI project, and I'm kicking out the console view model. Console view model, if I would relaunch the WPF project, you would see a console popping up for all the logging stuff. We're not doing that for Maui to keep things simple, which also means I need to remove it from the locator. There we go. Let's see if we can build still. All right, errors. That's good. That's exactly what we needed. So if I open up the main view model that just copied from the WPF project into the Maui project, you will start seeing a lot of errors because writable bitmap doesn't exist, for example. And I can already remove this. So now we got the task of cleaning this thing up. And before we do, I need to make sure that our view model locator is well known. So I'm adding a static property into the app class. Thank you, Copilot. Let's change this namespace. Let's change this namespace. I remove. ReSharper is not working with me. There we go. There we go. Using doomsharp.maui.viewModels. There we go. So I got my locator static property set up. Let's jump back here and remove some usings that we're not using. There we go. All right, so writable bitmap. I tried to find a substitute for writable bitmap in Maui. There is a 2D library included in Maui, but that did not suffice. It did not do the things we wanted to do. For example, if I scroll down a bit, there are two methods here that are really important for running our game. That's the update palette method and the screen ready method. Now what this does is, for the updates palette, I'm just gonna pull up the next slide here, just like this. So the writable bitmap or DOOM works with an indexed 8 image, meaning that we are not getting an array of pixels, we are getting an array of addresses. And there is a table filled with this address means this color, which is what you see in a simplified version here on the slide. So this is our palette, the image on the right here. It says 0 is blue, 1 is red, 2 is green. Then we get our image, our array of pixels basically, and that just contains zeros, ones, and twos. Writable bitmap will take those addresses and replace them with the colors, thus creating the actual image. That's index 8 image. It's an older way of doing things, which is why it's less supported these days, but writable bitmap can still do it. We can pass the indexed 8 format here on WPF again. So update palettes means create a new palette in case the table of colors and addresses needs to change, different colors, more addresses, something like that. As screen ready, the output byte array that we get here is the actual array of images or of addresses that we need to replace with pixels. So in the screen ready method, we do the actual replacements. Bitmap here is the writable bitmap. It has a write pixels method. We pass in the array of addresses. We pass in the palette, which it already knows, and then it will do all the magic. Now, this is one of the things the image or the 2D library included in Maui cannot do, among other things. And then the replacement I found for writable bitmap, and you might have heard of this, is a library called SkiaSharp. SkiaSharp is a C# version of the Skia library, which is made by Google, that can do all sorts of fun stuff with graphics. So first I installed the SkiaSharp library into my Maui project, followed by the SkiaSharp views.maui.controls. So I need the library in order to do all my manipulations. And then I need the controls library so I can put a canvas on screen and render my images onto that canvas. That's why I need the two. Going back to the main view model, scrolling up a bit, I should be able to replace this with an SK bitmap. And add a using statement. Before I forget, in order to use SkiaSharp, I need to use or add these methods into the startup. Again, for people not used to MAUI, they've reused the builder pattern that is becoming quite common thanks to ASP.NET. So in order to set up a MAUI project, you can now also use a create builder pattern and just add or just chain extra setup methods in there with this. Fun fact, a couple of conferences ago, I forgot this line and I blamed the MAUI folks that it wasn't working. And then they came to me, hey, did you add this line? Yeah, sorry. So I will never again forget that line. All right, writable bitmaps. Let's replace writable bitmap with SK bitmap, wherever. All right. The invoke methods. Dispatcher.invoke in WPF means that take whatever code is in this block and just run it on the UI thread. No matter where you are now, this needs to run on the UI thread. If you've ever done XAML and you've played around with data binding, you will have run into this, probably. Invoke doesn't exist in MAUI. It's called dispatch. Because using the same things matter. There we go. Don't worry about these lines. We will replace them in a sec. We are getting there. The only thing missing in the main view model is the int32 rect, a rectangle. This is an included thing in the WPF SDK. It's there, it exists. It doesn't exist in MAUI, but it's also a very simple struct. So I prepared it here as a snippet. And I will add it at the bottom of the file. It's a struct that takes an x and y coordinates and a width and height. It's a rectangle. Simple as that. With that, I'm almost there. Write pixels. All right, so the bitmap.write pixels, the part that will actually use writable bitmap to create whatever, we can replace with bitmap equals Skia bitmap dot decode. That's way too much. CodePilot output is enough. And then we no longer need this. There we go. So there's that. And then we need some XAML. I'm going to walk you through this, but I've prepared some snippets just to not type everything. There we go. I do have some stuff missing that I will just copy in and explain to you. Replace files. There we go. So what I did here, I made a custom control called game control. Because this thing will run on mobile devices, you don't have a keyboard, you don't have your arrow keys, so you need a way to control it, which means virtual buttons. Virtual buttons are not default control in MAUI, which makes sense. So I created a game control, and the reason this exists now because it was in the folder that I just copied in, and it should live right here. And it's basically an image that contains a key property. What I will do is I will add listeners to the image in order for touch events, and because of the key, which is defined for every image on here, every key references a certain physical key on a keyboard. And we just pass that into the Doom engine, and it knows how to handle it. So quickly looking back to the main view model, every key press will trigger an event, which is custom event system. It's nothing to do with .NET events. And that event gets queued into the events queue of Doom. And every tick, we will dequeue the next event and just push it into the engine, and the engine will take care of it. And since that is all in the shared library, I had nothing to fix there. That just worked, which was great. All right, some stuff left. Let's see here. Main window in WPF. This will actually, well, no longer be called run, but will be called run async. No, not there. But here. There we go. So when I copied in the folder just now, I also copied in a new version of the Doom game class. And the run method that I showed in the beginning is now a run async method. It's an overload, so it can take in some extra parameters, which I will show you later. This will actually, on initialize in WPF, run the game. So we need something similar in MAUI, which is here called on appearing. And this needs to be async. There we go. Yeah, something like that. Let's go back to the main view model. Just comment these out so we can build this thing. Hopefully. All right, we have duplicate file names. Resources, images. .NET bot is in there 2 times. Let's get rid of that. Try this again. Yeah. Why are my builds failing? Right. No matter, we'll just continue. It will start working eventually. All right, so remember when we started and I was showing you the run methods, there was this identify version method that looked at the WAT file. The WAT file is not there yet, so I'm just going to add it into the resources folder. Now the resources folder in MAUI is something specific. It's a folder where you can add images or fonts, or icons or whatever. And depending on the subfolder you put it in, your build pipeline will do different things with it. So if I want to keep the file as is and just put it into the container, I need to put it into the raw folder. So this is now there. If I build this and ship this, the WAT file is included in the actual application, which is what I wanted. But now, I need to take this identify version thing that was also in the engine, but actually uses Win32 APIs to check the file system, which is not usable in MAUI. I need to do it a different way. I need this to be in my main page. Let's close some tabs, do some cleanup. There we go. So the way to do it in MAUI is to use your file system APIs. And there they have a method that says app package file exists, async. So this checks if these files all exist, and based on the name, they will set a version which is a tuple of game mode and string, and just set it to whatever version this is and what the path of the WAT file is, or the name. It will return that version, and then I've got yet another snippet. It will take that version and pass it into the overload of the run async method, basically taking the identify version responsibility away from the engine and putting it into the MAUI project itself. Right. So this also means that the Doom engine can no longer load the WAT file in one particular way. We need two ways of doing this, which is why it got abstracted. The core engine now has a WAT file collection. It has a an iWAT stream provider, which gets implemented both by MAUI and WPF, and provides a way using the respective APIs to actually open the file as well. Once it's loaded, once the data is in memory, we can just go ahead and use the same way we were using before. But the loading itself was particular to MAUI. All right, we do need some more setup right here. We need to initialize our WAT file collection. New WAT stream provider. Like this, and then there's the Doom game set output render, which will be the main view model dot instance, not main activity, main view model. Like this. And what this does is we're basically telling the Doom engine, whenever you call your rendering methods, call them onto this instance, onto this class. And that will make sure that the updates palette and the screen ready methods are getting triggered. And then don't forget your binding context. And that will also be the main view model dot instance. Just adding some missing usings. There we go. Of course it does. This does as well. All right, I'm quickly going to restart Visual Studio because something is messed up. Oop. All right, we should be getting to the point where this is actually runs and renders if it builds. Which also shows that software development is not an exact science. Let's give it some time to load. Let's see, have we done that? We've done that. Build solution. While this is going, I'm going to prepare the next snippet, and maybe I can just show you here. So now we're going to replace the update palette and the screen ready methods. Because I just commented out some code in those two methods just to make sure it builds, but it's not actually running. I still need to find a way to do the palette replacements, or to take the addresses and put the pixels in place. There's no support for index 8 in SkiaSharp, as I've mentioned. So we need to do this ourselves, which basically means creating a bitmap with the correct width and height, and just loop over the widths and the height. So we're basically going row by row for every screen that we're rendering. And we are replacing the RGB values with the correct values from the palette manually. So we've basically built our own index 8 system. And once the bitmap is created, we're setting it to the output, and the output property is a Skia bitmap that we're binding onto a Skia canvas on screen, which in theory should make sure everything renders. Something is off. Anyway. Oh, that was the wrong one. Copy and paste. There we go. The same, but with colors. Let me just clean up. Small little tool I wrote to remove all the bin and obj folders from a folder that you select. I tried this demo this morning as a form of dry run. And what I then usually do is I git reset everything to throw everything away, but some things, some symbols might have been left behind. So what you will see if this actually compiles and runs is you will actually see Doom running. And if I wait for the Doom demo to run, it will work, but it will, and it's not really that noticeable, but it will be slow. It will stutter a bit, which has to do with what we're doing here in the screen ready method, with the manual replacing of the pixels. Hey, build succeeded. Look at that. Now let's see if this runs. Come on. That's a good sign. That's even a better sign. There we go. We got some virtual buttons. We got Doom. There we go. I don't know if you can see it on the projection, but it stutters a bit. It's not as fluent as it should be, even though this is a really old game. So in order to fix this, I did what every smart developer does, and I asked someone else to fix it. I went to Wesley and said, I don't know what to do anymore. You know more about graphics than I do. Can you help me? So he went to work, and he fixed it. And I'm just going to add some more snippets and then talk you through the fix. It was not an easy fix. We spent some time figuring this out. And this is where the magic is. So again, we replace this. And here's an unsafe statement. And unsafe is not supported by default. You need to add something to your CS file in order for this to work. What unsafe does is, whatever code is in this unsafe block will not be managed memory. You're basically on your own. You're telling your garbage collector, I know what I'm doing, leave me alone. You're in pointer land here, which is why I asked someone else. So we're basically doing the same thing. We're manually copying pixels over pixel addresses, but in an unmanaged way now, which made quite a big difference. Just need to fix some more stuff. Dot instance bitmap rendered. We need this one. This is a new event that was just added by the snippets. And then there's just one more snippet, number 7, which we need to add on paint surface right here. So this is the actual event that's being triggered in order to, let's just take a step back. Going to the XAML, there's a canvas view. Whenever this canvas view gets invalidated, it needs to re-render, it calls this method. What that method does is it takes the data from the view model and renders it on a certain place, in a certain width, a certain height, some graphic magic. All right, let's see. Did I forget anything? I think not. Let's try this again. And if everything goes well, this should still work, but faster. There we go, very smooth. And now that you see this version, you can actually see the big difference between the two. So that got fixed. The only problem we had is when we ran this on Windows, it looked perfectly fine. But then we ran it on Android. Wait, do I have that screenshot somewhere? I think so. Let's go here, then there. I think it's number 2. This is what it looked like on Android. Not what you would expect. Turns out that, and the code is already in here to fix this, if you create a Skia color on Android, the R and the B value are inverted. Is it R and B? Yes, it is. Yeah. So those are inverted. So if Android, do it like this. If Windows, or if not Android, do it like this. I don't know why. It was a fun thing to see happen. All right. So with that, we now have Doom running. We have a performant version of Doom running. We even have the correct colors on Android. Imagine that. But we cannot control it because our game controls, our images, our virtual touch buttons are not doing anything yet. So we need to fix that. And in order to fix that, there is a slide detailing how this works. This is how controls work on MAUI. So again, at the bottom you have your native views, and in this example it's a button. You have your native UI button on iOS, you have your native app compat button on Android, and you have your button on Windows. On top of that are abstractions called handlers. And handlers are MAUI classes, just calling into the native platform controls. Every handler has an abstraction in the form of an interface, which in this case is iButton. And iButton gets implemented by button, which is abstraction on the highest level. So if in XAML, in MAUI, we add a button element, this gets called into an iButton, which becomes a button handler, which becomes the native button on whatever platform you're running on. Why is this important? Because we can use these handlers to extend what these controls can do. For example, every control in MAUI has a touch event. You can add touch to anything. But we don't just want touch. This is a game. We want to be able to keep a button pressed so we can run forward. That's not supported. But every platform by itself does contain key up and key down events, which is what we need. But there's no abstraction on MAUI level, so we need to add that ourselves. Going back to code, how do we do this? We go to the main page, to the onAppearing, which will trigger whenever the page is rendering. And then we add, let's add it here at the bottom. We take our image handler. We take the mapper, and then we can append to the mapping. It needs a key, which we will call touch support. And then we can add an action to it, like this. 2 parameters, handler and view. Handler is just your image handler, which is MAUI land. View is your image, your MAUI image. Like this. We have yet another snippet to add. Now we only want this code to run in case we are actually having a game control. This will now run for every single image because it's an image handler. There's no such thing as a game control handler because game control is just a class that inherits from image. So we do a type check. If we have an actual game control and we're running on Windows, then we can use the platform view. And if you zoom in a bit, you will see this is an actual Microsoft UI XAML control. This is a WinUI image. Not a MAUI image, WinUI. If I would switch here to Android, for example, then this will light up. And the platform view will be an Android image view. If we would add iOS here as well, then platform view will be an iOS UI image probably. But I'm going to stick to Windows for now. There we go. So now we can call into the events of the native platform control, which is perfect, exactly what we needed. Let's take this one, scroll a bit, and this goes into the main view model, somewhere at the bottom, like this. So what this does is, it's the on-key action and the translate key. So we will take the virtual button that was pressed, the virtual key, we will translate it into a physical key, and that will go straight into the event queue of Doom. There we go. Now, if I did everything correctly, which I apparently didn't, all right, it added a using statement that doesn't exist on Windows, and some other stuff. What do you mean you don't know what initialized component is? Of course you do. What's going on all of a sudden? Oh well, let's just try this one again. Clean everything. There we go. Build. If this doesn't work, it doesn't really matter. I can promise you that this does work. Buttons are actually working now. Whatever, let's just skip that part. One thing I was thinking when building this is, okay, we now have touch controls on our mobile platforms, but we need actual button support as well. I'm running on a Windows machine. I have a physical keyboard. I need to be able to do this. Now, there is inputs control in MAUI, but it's only when you have focused in like a text box, for example. Then you can enter with the physical keyboard. There is no way to say, hey, I'm on a screen and nothing has focus, please read my keys. That doesn't work out of the box. So I need to find a way around this. And what I did was I wrote a behavior. And a behavior is a way to write platform-specific logic and create an abstraction so that you can use it in multi-platform land. So in this case, I got a keyboard behavior that's not supported on Android and not supported on iOS. Pretty naive, I know. iOS, Android have keyboards, but I didn't feel like implementing those. So I went to Windows only. And they have two events, key up, key down. And if I go to the Windows implementation uncommented, you need to inherit from platform behavior, and then you have your MAUI element and your native element, and it will merge those two kind of together. And I'm doing this on UI element. If you look at the Microsoft UI XAML, UI element is somewhere up there in the visual tree, somewhere on top. Almost everything inherits from UI element, so we're good with that one. So what I'm doing is I need to find the outermost element in my visual tree. So visual tree, for those of you not familiar with XAML, is kind of like your DOM in HTML, but then for XAML. And there are like helpers, like the visual tree helper, that you can use to inspect that visual tree and change it at runtime. Reflection, but for UI. So when looking at the visual tree of a MAUI application, you have quite a big tree, and it's elements, 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 and it's all MAUI, 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 until you get to the topmost element. The root element of everything is a native element, always. So what I did was, I traversed the visual tree all the way to the top to get that native element. Once I had that, I could add the key up and key down events on that element. Now, that element always has some form of focus because it's the outermost, so those events will always trigger. Whenever they get triggered, I would invoke the key up and key down event that is here in my abstraction. And then here, I would create a behavior, take this snippet, and put it somewhere right here, for example. Right, so I would create a behavior, wire up those two events, and then there's a behavior list on every element. Every MAUI element has behaviors. You can just add to it. And now these things will fire when I hit my hardware keys, and they will go in the on-key action, the exact same one that's being used here by the virtual keys. And from that point on, it's again the engine's problem, and everything is working. One more try to make it work. It will probably fail, because this is not here. It does recognize initialized component now, so who knows? Oh, there we go. It's working again. I'm pressing the space bar on my keyboards. That's working. Clicking the A button. That's working. Pushing escape. The menu loads. So I have both physical and virtual keys running now. And with that, my port was completed. Afterwards, we added sound and everything as well. So that's also working in the version that's out on GitHub, but I did not put it into the demo because it would be too long. All right, going back to the last couple of slides. So my key takeaway in all of this is that this project was incredibly fun to do. I spent a lot of free time on this, and this was so much fun. Every step that you made and you run to the next problem was like a small victory, because we got further, the next problem is there, until there was no more problem, everything was working. So the key takeaway that I want you to take in from this session is that we as developers, we have an entire playground to have fun. Don't forget to have fun with what you can do, with what you know. Try and do these things that are basically completely useless, but are so much fun to do. Don't forget the fun factor in your job. It's the best part of it. That's a major takeaway. This is here for some reason, I don't know why. Just remember this slide when you walk out. Right? Really important. This is the link to the GitHub. Feel free to take a picture of it. Go and see what we've done, clone it, play around with it. Sound is in that version. There are even some ideas of adding accelerometer support so that if you're running on your phone, you can actually walk around and the game will follow you. That apparently accelerometer that didn't work yet in MAUI, so need to find some time to fix that. If you are interested, do it, send a pull request. We would be happy to merge it in. I got about 5 minutes left. Are there any questions? But you need to be loud because there's a lot of noise coming from the back.
How did you implement the sound? Did you use a specific library?
Yes. So how did I implement the sounds? We did use a specific library, fmod, I believe it was, which is not available as a NuGet package. So we actually had to pull the DLL into the application. DLL hell all over again. And that actually did also work on MAUI. So we first did it in WPF, and then we took fmod into MAUI as well. And that made it took some tweaks here and there, but we made it work using that one. All right, yes?
Are there the support for hardware acceleration in MAUI?
For hardware acceleration? I don't think so. I'm not sure. MAUI is not a game engine. And you've seen this in the code. So the question was, is there hardware acceleration support in MAUI? I don't think so because it's not a game engine. We're basically just messing around with bitmaps. So I don't think we can make it hardware accelerated. Yes? I did not understand that one. Can you speak up a bit? Is the app available in the app stores? No, it's not, because we are not allowed to ship the WAT file. If that wasn't an issue, then it would have been available in the app stores, probably, yeah. Fun thing is that Wesley actually ran into John Carmack a while back and let him play our clone. So that was fun. All right. With that, thank you all so much for being here. I hope you enjoyed it. Don't forget the takeaway, and please vote on your way out. If you have any other questions, I'm here for most of the conference, so feel free to come up to me and have a chat. Thank you so much.